Hi everyone, and welcome back to the HexCatFace channel. Today we'll be designing a sauna water heater. First of all, so what exactly is a sauna water heater? So this is an actual product that you can buy. If you've got a wood burning sauna, the idea is that this comes between your chimney and the stove, and the flue gases go through this heater and heat up the water. Um, so why design a custom one then? So a little background for that. So this is the sauna that I'm designing this for. So it used to be an electric sauna that is being turned into a wood burning one. And there's quite a few installation constraints in this sauna. So underneath this chimney here, there's a drain and the stove can't be placed there due to fire safety concerns. And the chimney can't be moved over the stove since there are roof structures in the way. So we need to do a 300 mm offset. And I thought about doing this in the water heater, but this is advantageous to us as we get more surface area to heat up the water. So this is what we'll be designing today. It's the water heater with the offset, and it's made in sheet metal in Plasticity. And since plasticity doesn't have the ability to make flat patterns, you'll have to make those by hand. So stay tuned. So now we've got a new plasticity document open. So let's start making the water heater. And let's start off with the side dimensions. Let's start by making a square or a rectangle here and hit C to center it around the origin. And then I want something like 510 by 500. And the offset for the pipe needed to be 300 mm. So let's make a 300 mm a reference line here. And GF and center the reference line. And let's take a reference from this point and make a vertical line here. Something like 30 mm. And Shift D to duplicate this and pick the top of this line and take a reference from this point and put it at the top of this box. And then join these lines together. And J to join these lines. And I want the water heater to take 50 liters of water. And the pipe itself takes a bit of volume. So let's first model it as a closed pipe so that we can get the volume. Something like the pipe is 114.3. And I've noticed that the sweep doesn't work if there's too many lines in the way. So we need to remove this box for the sweep to work. So let's select this circle and then sweep. It seems to work. And then select this line here, this polyline. Now we've got our pipe. And we wanted the water heater to be 500 and 510. The depth doesn't matter as much. So we'll make the depth so that the water heater holds the 50 liters of water. So let's calculate what the depth should be. So we get the volume here. So what I like to use this, so when I'm calculating something like this, the program that I like to use is calculate, or the command line program is calc, VAQ. So 500 mil times 510 millimeters times x, and this is the depth. And then we need the volume of the pipe. So we can see this here, the volume. If we click on it, it copies to our clipboard. And we need to take out these 1000 separators. And that is millimeters cubed equals 50 liters. So the x should be 219.9, so 220 millimeters. So let's start modeling this. And I would like for the sides to be, I would like for the top and bottom face to be separate sheets, and the sides to be made out of like two L's. I'll show you that in a bit. So let's start making a rectangle here, and then again press C. Then this was 220, and this was 510. And let's extrude this as a surface. So E to extrude, and we're only selecting the edges to get a surface. And we need to extrude this in both directions. And it was 500, so 250 and negative 250. Now we've got a surface here. So two L's like this. So this is one of the L's. So this face and this face becomes an L shape. So let's make an inner radius here. And this is dependent on what sort of tool do you have in your brake press. So for me, I'm using 1 millimeter for the inner radius. And then select all of these faces. And then thicken. So negative 2 millimeters. Hold on, we didn't we didn't have the radius, so no, it was doing it in the wrong way. So thicken. You should check which side does it do it in. So it has to be. It doesn't have. It needs to be positive. So 2 millimeters. So now we get it in the wrong in the in the right direction. And we can remove the original surface from here. And let's duplicate this one, Shift D, then rotate it by 180 degrees. And it isn't quite aligned yet, but we'll align this. So G, F, and then pick this edge and place it here, get it aligned. And I want these faces to come on top of the on this face and leave a bit of room for welding. So maybe I'll move this by like 1 millimeter. So it's halfway of this face. You could duplicate again, but this is a bit faster to do this way. So 1 millimeter. And now let's make the top and the bottom faces. So let's make a square here. We'll take 2 references from this point and this point. And then let's go do the other side. And 2 references from this point and this point. Now we've got our top face. And we want to fillet this. So fillet. And as we had the inner radius be 1 millimeter, and we add a 2 millimeter thickness to it, the outer radius is 3 millimeters. So let's make a 3 millimeter radius all around. Okay. And then let's move this up to the top. So let's select this edge, GF, select this curve, and then go to the top of the box and hit Z to constrain it to the Z axis. And let's extrude it. So select this face and then extrude by 2 millimeters. Maybe I would like to shrink this a bit so we have some room for welding. So maybe shrink it by 1 millimeter. So I'll have to select all of the outer faces to shrink this. You could do this bit by scaling, but scaling uses percentages, and I don't really know the percentage for this. So let's move this by -1. Like this. It also changes the radius. So I think I'm fine with that. It follows sort of the radius in the middle here. And it looks nice, I think. And then let's mirror this. So Alt X, and then mirror it to the bottom. Now we've got our box. Maybe hide the bottom one for a bit, and let's delete the original pipe that we had, and let's make this hollow now. So let's offset this circle by like -1. And now let's sweep this hollow section. So sweep. And for some reason the sweep doesn't seem to okay, sweep. Sweep. Okay, now. Oh, it worked. Maybe I wasn't clicking it. I was just hitting enter. Okay, there we go. We have the hollow pipe. Now let's show the bottom cover here. We had the outer edge here. Let's move that, and we'll punch a hole through this bottom face here. And hit W for the difference. And now we have a hole for the pipe. Maybe I'll use this pipe and Shift D, and then move this edge a bit up here, and then punch a hole here as well. So, and then W, and then click on this top face. And then we need the fill gap, or the hole that we fill the heater from. So let's place the hole on the other side, or on the at the same location as where this hole is, but on the other side. So let's GF, or maybe it's just G, and then bring it all the way up to the top. And then let me punch a hole here. Like this. And then we need some tolerances for the pipes go through. So something like a millimeter. So we need to push these faces by a half of a millimeter. Maybe this hole can be a bit more bigger, so maybe 2 millimeters bigger than the pipe. So push this by a millimeter, so we get 2 millimeters. That's it. Changes the radius. And then let's pull the pipes out a bit. Hold on, let me remove these lines so they're not in the way. And GF, and pull this up to the top, and constrain it by Z, by hitting Z. And then maybe I still want to move this up by something like 100 mil. Let's do the exact same thing here. GF, and constrain it to the Z, and move this down. Hold on. Move this down to 100. Now we need to make the lid for the for this fill gap here. So let's make a lid from the same material as the pipe. So I'll show you in a bit what I mean. So let's duplicate these, Shift D, and then move these up to the hole. So constrain it to Z again with Z. Let's extrude this face down by like 10 millimeters. Let's remove these curves again, like they don't get in the way. And then a top face for the lid, something like 180 millimeters diameter. And let's extrude this something like 5 millimeters, I think. Should we go with the theme and make it 2 millimeters? My 5 is all right here. And for the handle, I think 120 mil sounds about right for the width. So let's duplicate this and select this edge here or this end here and place it on the center. Say a corner rectangle, and then 3 millimeters and something like 25 for the. I want the handle to be the same size as this tab here. GF, move it to the middle. Shift D, duplicate it. F. Then let's extrude these faces or these tabs. Maybe something like 50 millimeters to get a bit of height so that we can get our hand on the handle. Let's make a circle here for the handle, 25 millimeters. Let's extrude that. Extrude it a bit and then GF and then go to the other side. Shift D. I want the dabs to have a round edge at the end. So let's extrude that. It was 3 millimeters, and then Q and select the dab that you want to union it with. Maybe I would like this to be a bit more to have a bit more width than the handle, maybe like a millimeter. And let's make a hole, because this is a wooden handle, and we're gonna drill the or we're going to put a screw at the end and hold the handle with a screw. Something like a 4 millimeter hole here. GF, and then put it at the on this edge of the tab. So constrain it with X. Then let's punch a hole through it. So just extrude and then W and then the tab that we're making the hole to. And let's chamfer this hole so that the screw doesn't poke out. So something like a -2, and we've got still a millimeter left for the. So it isn't completely sharp to the edge. Let's delete this one, as we can mirror the dab that we just made. There we go. Then for the tap, so for us to get the water out. So at MacMaster Car, I found this medium pressure stainless steel threaded pipe fitting, and they got it in 3/4 inches. So that's what I'm using. You can download these by hitting the model number here. You can download it as a SolidWorks file or a step file. So I downloaded it as a step file. So let's import this here. GF, or maybe just G, and then move it out from the box or from the heater, and then rotate it around 90 degrees. And then we'll have to place it on the hole here, or on the face here. All right, so let's place the pipe fitting. So let's select the center from here. Let's go to the side view so it stays at the center. And we want to pull it all the way down here to the edge. There we go. Now, how much do we want to move this up? Something like 40 millimeters. I think that looks fine. And then let's draw a line, a reference line here, so we can get the center of this model. Then select the model, GF, and select the center of this line. So now the center is at the surface here, and we'll use this to punch the hole. So Q and then difference and keep tools. So select this to so it doesn't remove the thread fitting or the pipe fitting. Hold on, I did it the wrong way, so it got the thread or the pipe fitting. So first select the thing that you want to cut it from, and then select the cutting tool. So Q and then difference and then keep tools, and select and delete the middle bit that was left. There we go. A sauna water heater. I think this video is a bit too long, so maybe I'll leave the flat patterns for a part 2. So subscribe to my channel if you're interested in that. It'll be coming soon. Thanks for watching.